Hey guys, welcome to Safi Mixed. In this video, I want to solve a very interesting problem of mechanics and will give you a very good concept about the motion of a rod which is standing. This is a rod, and let me represent this point B and this point A, and let L be the length, and let me call this the origin, and let me represent this. Let me put the A over here and represent this, the distance x, that is OA is distance x. And similarly, let me put B over here, and this is then y. Now, if the end B of the rod is falling with certain uniform velocity Vy, that's then obviously, since the length of the rod is not changing, and that is possible only if this end of the rod is moving horizontally, I call this Vx, and I'll consider this positive direction, and similarly the upward is positive direction. This is I call y-axis, and this I'll call x-axis. So I'm taking the positive x to be towards left. Then the question is, if this end is falling with velocity Vy, what would be the value of velocity Vx? Will these two velocities be different, or they be the same? So we want to find an answer to this question. But before answering it, let me point out one thing more. If the velocity of this end is uniform, that is Vy constant, then that means there must be friction between the end A and the floor. If there were no friction, this would have been a free fall, and in free fall, Vy would not be then constant. So we conclude that if the velocity upon B is constant, then there must be friction between the floor and A of the rod. Nevertheless, I can use the Pythagorean theorem to write down, because this construct a right angle triangle, so I can write, okay, let me write one thing more. OB is in fact equal to y, the distance along vertical. So now I can write L squared equals x squared plus y squared. That's what I can write from Pythagorean theorem. And now if I differentiate, since with time this is falling in the downward direction, this is moving towards the left, so the distance along vertical is decreasing constantly as the time goes on, and the distance along horizontal increases from the origin. So I want to differentiate both sides of this equation with respect to time, and mean I can write d over dt into L squared equals d over dt into x squared plus d over dt into y squared. And if I apply the derivative or the operator, this side can be written as 2 times L dL over dt. This term becomes 2 times x dx over dt, and this becomes 2 times y dy over dt. Okay, I can draw 2, because dividing the whole equation with 2 will cancel 2. And one thing more, since L is the length of rod and it is not changing with time, that is constant, therefore this derivative goes to 0. So this whole side is 0, and I can write this side in the form x dx over dt plus y dy over dt, and this equals 0. I have inverted the whole equation. Now Furthermore, I can write this as dx over dt equals minus y divided by x. I'm first taking this to this side to become negative, and then divide both sides with x to write it over here, and this will become dy over dt. Now, dx over dt is in fact the velocity along x-axis, and dy by dt is the velocity along y-axis. But keep in mind, this is opposite to the direction of y. So because we are taking the upward direction is positive, so it is in the downward direction. Therefore, I can write this thing like y divided by x into minus dy divided by dt. Now, dy is by itself negative because with the passage of time, this distance is decreasing, so dy would be negative. And vy is also negative, so this thing is in fact the positive velocity. I write this as y over x into vy. Okay, now let me write things over here. We want to eliminate the information of y from this one equation because we only know about this. And in order to eliminate that, I can use this equation. From this, I can write y squared equals L squared minus x squared, or I can write y equals L squared minus x squared square root. If I replace this value at this position, then I can write dx over dt equals square root L squared minus x squared divided with x into vy, or I can manipulate this to write it the whole square root L squared minus x squared divided by x squared. That is, I square this and take the square root, so that is back equal to this thing, and I write vy over here. Okay, let me rub this thing out, and I want to write the rest of the things over here. From this, I can write dx over dt equals L squared divided by x squared minus 1, because x squared divided by x squared would give me minus 1 into vy. So we see that our vx equals square root L squared over x squared minus 1 into vy. So we see that the two velocities are not equal. Rather, the velocities, or the ratio of the velocity is equal to this thing. So what do we have? What is the behavior of this factor when x is equal to 0, right? When x equal to 0, that means we are at this position because this is the distance x. And anything divided by 0 is infinity. Infinity minus 1 is again infinity. And this equation then say that this side is infinity. So I can write this as vx over vy would become infinity. That means when x is equal to 0, vy would be equal to 0 only, then this thing would go to infinity. So if we place the rod right vertically, there will be no slipping then, and vy would be equal to 0. However, on the other hand, what happens to the velocity vx when x is increasing, that is, it is moving in this direction, this whole term is decreasing, and this is constant, so overall this thing is decreasing. This is constant. If this is decreasing, that means vx is decreasing. So with the passage of time, what happens, the rod, the NA of the rod is moving in this direction, but the velocity is constant, decreasing. And at x is equal to L, this thing is 1, and 1 minus 1 is 0, and vx becomes 0. So In fact, for Vy being constant, Vx is constantly decreasing from certain higher value in reaching to zero. So the velocities of the two ends of the rod are not equal. If the vertical velocity or the velocity of point B is constant, so then this relation represents the lengths the so then this relation links the two velocities. Thanks for watching.